Hi everyone. So for this practice problem, we have an optimization problem where there's a rectangular deck that's constructed with one side that's a wall and the other three sides that are fencing. And I have like a little diagram here. And it says that there are 24 yards of fencing available. So we want to determine the dimensions that will create the deck of a maximum area. And what is the maximum area? So first let's note that we're going to talk about the perimeter because we know that there are 24 yards of total fencing available. So we know that if we add up our three sides of fencing, that it should equal 24 yards. So we know that 2W plus 1L is going to equal 24. And then we are trying to maximize the area. So we know that the area of a rectangle is length times width. Well, I want to express the area in terms of just one other variable, not two. So I'm going to solve this perimeter equation for one of the variables. And the easiest one to solve for is L. So if I subtract that 2W over, we'll have 24 minus 2W. And so I can rewrite the area equation as 24 minus 2W times W. And if I distribute that W on the end, we'll have 24W minus 2W squared. So we're trying to maximize the area, which means that we are looking for a relative maximum. Or an absolute maximum, actually. Notice that this is the graph. The graph of this function would be a parabola facing down. So it makes sense that we have a maximum value. So to find our maximum value, we're going to find a critical value and then use our first derivative test to make sure that it's a maximum. So let's find the derivative of A, the derivative of the area, in terms of the width. And that is going to equal 24 minus 4W. And then to find our critical value, we're going to set this equal to 0 and solve for W. So I'll have 4W equal to 24 or W equal to 6. And just to make sure that this is a maximum, we can just test on either side of 6. So if I pick a value smaller than 6, like 0, and we put it into our derivative function here, so I'm putting it into here, I will have a positive number, because 24 minus 4 times 0 is going to give me 24. If I pick a number bigger than 6, I don't know, 10, and again, I'm putting it into this derivative function, I've got 24 minus 4 times 10. 24 minus 40 is going to give me a negative number. So the function is increasing until we get to 6, and then it's decreasing, which means that this 6 is our local max. So the question asks us it says determine the dimensions that will create the deck of maximum area, and then what is the maximum area. So notice that right now I've only got one of the dimensions. I have that the width is 6 in order to maximize my area. So the maximum area will have a width of 6. So then I want to find the length. The length is going to be 24 minus 2 times 6, or 24 minus 12, which is 12. So the dimensions will be, do I have units here? Yards. So the dimensions will be 6 yards by 12 yards. And then what is the maximum area? Well, the max area, we know area is length times width. So this will be 12 times 6, or 70 let me write here, 72 yards squared.